In-class activity 11G, connecting tests and intervals. Recall the 2004 study by two University of Chicago economists who wanted to test for labor market discrimination. The results, which we analyzed in the last in-class activity, are summarized in the following table. The table shows callback, not callback, commonly white names, commonly black names, and the total. We have 246 called back for the white names, 164 called back for the black names, 2199 not called back for the white names, 2,281 not called back for the black names. The total is 2445, 2445 in both cases, a grand total of 4,890 participants. We define P1 as the true proportion of commonly white name resumes that received callback. P2 is the true proportion of commonly black name resumes that received callback. Question 1. Number 1. In the previous in-class activity, we conducted a two-sample Z-test for proportions to test if commonly white names received a truly higher callback proportion than the commonly black names. Write down the hypothesis we use for this test and write a brief explanation of what each hypothesis means. Here is the answer. For the null hypothesis, we used P1 minus P2 equals 0. For the alternative hypothesis, HA, P1 minus P2 is not equal to 0. A brief explanation. The null hypothesis states that the callback proportions are equal. The alternative suggests the true callback proportion differs between name groups. Here are the objectives for the study. You will understand that the significance level of a two-sided test corresponds to the confidence level subtracted from 1. A statistic inside an interval usually corresponds to a significant test, to an insignificant test result for two-sided result. Let's say it again. A statistic inside an interval usually corresponds to an insignificant test result for two-sided test. A statistics outside an interval usually corresponds to a significant test result for two-sided result, for two-sided tests. We will be able to draw connections between confidence intervals and hypothesis tests. Number 2, recall that all the conditions for inference were met. The Z-test statistic value was 4.23, and the p-value was very, very close to 0. What conclusion can we draw from these results? State your conclusion in context. Use the significance level alpha equals 0.05. This is our conclusion. Because our p-value is very low, we have convincing evidence to reject the null hypothesis and conclude that the callback proportions differ Specifically, it appears that commonly white names receive a higher callback proportion than commonly black names. Now, if we go to the DCMP compared to population proportions tool to this website, select number of successes option and input the relevant data from the study. Under the type of inference section, select confidence interval and a 95% confidence interval. A, write down the confidence interval. Looking at the results from the website, the confidence interval is between 0.018 and 0.049. After you input the figure into this online site, the Shiny apps. Shiny apps. Okay. B. What exactly is this interval estimating? Is it one proportion, two proportions, a combination of proportions? Please explain. Well, the interval is estimating the difference in proportions of commonly white and black names that get callbacks. Specifically, it is estimating P1 minus P2. C, part C, says interpret your interval in the context of the study. Interpret your interval in the context of the study. There's the interpretation. We are 95% confident that the interval from 0.018 to 0.049 captures the true difference in callback proportion between commonly white and black names. Number 4, look back at the hypothesis for your test and your conclusion. Then look back at the confidence interval. Let's compare these results. Do the values in your interval support the hypothesis? Null alternative. That your significant test also supported? Explain. Again, do the values in your interval support the hypothesis that your significant test also supported? Please explain. Here's a sample answer, because answers may vary, but the main point will be the same. Sample answer. Yes, the test concluded that we had convincing evidence that the callback proportion differed. In other words, that the difference in callback proportion is not equal to the null value of 0. All values in our interval are above 0, meaning all plausible values for the difference in callback proportions are positive, non-zero. So these results align well. 4B, part 4, part B for number 4. If the interval contained in the null value 0, if the interval contained the null value 0, would it be consistent with the result of the significance test? Explain. No. The test concluded that there was a significant difference in callback proportion. If 0 is a plausible value, as indicated by our interval, the result is inconsistent. If that were the case, the result would be inconsistent. Confidence intervals contain a range of plausible estimates of the population parameter. We just consider the population parameter of the difference of proportions, P1 minus P2. But these results can extend to a confidence interval for any parameter, including one proportion P. The confidence intervals constructed in these activities were two-sided, since Z star is the point on the standard normal distribution such that the proportion of area under the curve between negative Z star and positive Z star is C, the confidence interval. The two-tailed confidence intervals with the confidence level C correspond to two-tailed hypothesis test with significant level 1 minus C. So the confidence C, the significance level 1 minus C. For example, a 95% confidence interval corresponds to a hypothesis test with the level of significance 5% or alpha 0.05. Similarly, 99% confidence interval corresponds to a hypothesis test with a level of significance equal to 1% or alpha equal 0.01. Let's connect these results to a one-sample test of proportion. Imagine you are a pollster. You randomly sample people in their county and ask them about their political leanings. Based on your sample, you create the following 95% confidence interval for the proportion of county voters who are Republican, 49% to 52%. Imagine you also conduct a hypothesis test with the following hypothesis. Null hypothesis, P equals 0.50. Alternative hypothesis, P is not equal to 0.50. If you were to conduct the hypothesis test, would it be safe to reject the null hypothesis and conclude that there is significant evidence that the proportion of county voters that are Republican is 50%? Explain. The answer is no. The interval includes the null value 50%. So it is plausible value. It should likely not be rejected. 50% is between 49 and 52. So it's a possible value that could lie here. So it is plausible. It should not be rejected based on that. B, in this context, which would provide more information? A hypothesis test, a confidence interval. Explain your reason. So comparing hypothesis test or confidence interval, which one would provide more information? This is the answer. The possible answers may vary. The confidence interval provides more information as it gives a range of plausible values for the proportion of the county that identifies as Republican. The hypothesis test would merely tell you how unusual the sampled value is compared to the one proposed proportion value, 50%. Six, recall the vaping effect example in in-class activity 11E. The NIDA was interested in the effects of the 2020 pandemic on drug abuse in teens. In particular, they were interested in the changes in vaping usage pre-pandemic and 3 months into the pandemic. Before the pandemic, 24% of 12th graders reported that they had vaped nicotine in the past 30 days. 3 months into the pandemic, 17% of 582 12th graders reported that they had vaped nicotine in the past 30 days. Which of the following provides more information in this context? Explain your reasoning. 1, or A, hypothesis test, and B is confidence interval. In hypothesis test, the null hypothesis for the study was null hypothesis H0, P equals 0.24. And the alternative hypothesis was P is not equal to 0.24. The test resulted on a p-value of less than 0.00. So we concluded there was sufficient evidence to conclude that the proportion of 12th graders who vaped within the last 30 days has changed from pre-pandemic to 3 months into the pandemic. For confidence interval, we are 95% confident that the true proportion of 12th graders who vaped within the last 30 days is indeed between 0.1396 and 0.2006. So, remember our question is, which of the following provides more information in this context? Explain your reason. The hypothesis test explained like this, or the confidence interval presented like this. Which of these two provides more information in this context? Answers will vary, but here is a possible explanation. As we said, answers will vary, but this is a sample answer. The confidence interval provides more information as it gives a range of plausible values for the proportion of the students who have vaped. The hypothesis test does not tell us if the vaping rates increase or decrease. The hypothesis test merely tells you how unusual the sampled value is compared to the one proposed proportion value, 24%. But the confidence interval gives us a range of values, a range of possible values. So the confidence interval provides more information. In conclusion, know that typically the conclusion drawn from a 2/3 confidence interval is usually the same as the conclusion drawn from a 2/3 hypothesis test. If a confidence interval of level contains the hypothesized parameter, then a hypothesis test at the 0.05 level of significance will almost always fail to reject the null hypothesis. If the 95% confidence interval does not contain the hypothesized parameter, then a hypothesis test at the 0.05 level will almost always reject the null hypothesis. While this does not always hold for tests of proportions, a confidence interval typically provides more information about reasonable values of the parameter. Again, make sure you watch this video with your lesson note printed and in front of you. Thank you, and we see you at the next video.